as you can see, this is an example of a sample that's going to be used as a PQR or a WQR. So I'm going to try to draw it for you and give you an idea of how it's going to be. So first, you can see that here we have our weld. There is our weld, okay? As you can see, okay, there is our weld. But this is just an example, right? So the plate should have actually been longer, okay? But this is a spare, as you can see, it's a spare. So it's in space, which was just in case something happens, right? So what we're gonna do in this case, we're gonna have to, according to the code that's gonna be used, we're gonna have to discard this part here. So this part here will be discarded, this part here. After discarding that part, okay, we're gonna have to discard this other part as well, okay, that part as well. So that's one need to be more or less 25 millimeter, okay, 25 millimeter, 25 millimeter. So once that is done, we're gonna go and after this, what we're gonna do is we're gonna cut our first tensile there. After cutting our first tensile, we're gonna cut 2 bends. Let's say that we are dealing with a ISO, so 2 bends there. So 1, 2 tensile, bends, and here again we come for our second tensile and 1, 2, 1, 2 bends. We're gonna have 1, 2, 3, 4 bends, 1, 2 tensiles. After doing that, we're gonna go for the impact, okay? We're gonna have our impact in the middle here. We're gonna get our impact and our macro somewhere there, right? So let's say that we are dealing with ASME. So ASME, you're gonna do the same. We're gonna discard 25 millimeter, more or less 25 millimeter. First tensile, first 2 bends, first tensile, first 2 bends, okay? No impact, no macro, unless the customer wants some, right? So this is eventually how it is done, right? So then I'm gonna show you how we cut it. So this is actually the sewing machine that cuts the sample. So you can see there is the saw blade, okay, and there is the sample. So this sample here is for fracture test or macro test, depending with the requirements or the standard code that is being used, right? So as I told you about the part that's going to be discarded. This is an example of the part that will be discarded in case you're doing what I just said here. So you discard something like 20 to 25 millimeter out of the sample that has been dropped, and then for the remaining part you cut either the macro and the fracture or macros only, depending on what the testing code is asking for. So yeah, now here I can show you now. This is the case of a plate, I said that plate should have been longer. This is an example of a longer plate. So here I'm having a tensile. So this is a tensile, right? And here I'm having the part that was discarded. You can see there, okay? So this part here was discarded, right? That side there, and then they cut. This is how it looks like, right? After discarding this part here and this one as well, these 2 parts we discarded. The first 20 to 25 millimeter of the plate, right? Because remember, this is just the beginning of the plate. So if you want to test this part, you might have a lot of stuff that you don't need in your sample, because you know what I mean, the beginning of the weld and the end of the welding, or the weld, whatever you call it, right? So then after cutting your discarded piece, then you're gonna go for the tensile, that is the tensile. Then I guess after this you're gonna have 1, 2 bend there, so the first and the second bend, and the other side you're gonna have the first tensile and 2 bends as well, right? I think yes, this is ASME or AWS, so they go together like that way, right? So this is kind the way it's done, right? So you can see I'm having even my shavings here, yeah? But I'm not wearing any gloves on me, so yeah, I'm just trying to give you an idea of how it is. So yeah, kind of this, right? So this one here is actually a sample that has been like dropped, and then here we are cutting the sample that's gonna be like discarded, and then here we're having our main piece that we're gonna use for tensile, bend test, macro test, impact test, and then all those that goes with it according to the requirements of the standard that's going to be used here, right? So So what are you doing here?
So right now I'm cutting a scrap. Firstly, you have to remove the scrap from the test piece that you are given, according to the job sheet and the instructions that you are given. So after I cut my scrap, I'm gonna cut. I have a tensile and 2 belts that are needed according to the description of this. So first, I have to remove my scrap from both sides. So that I have to cut like both sides of this test piece. Yeah, as you can see, I'm still learning the job. So thank you.
So this is how it goes. So you can see, that is the guy.
Yes, sir.
That's the guy doing it.
Yes, sir.
Cool. All right. Have to capture the data. So we're gonna have to capture the data. We're gonna have to start by capturing the thickness as I've done it now. So now here I'm gonna capture the width. So 90.11, and here I'm gonna capture the gauge length, which is 50 millimeters. Okay. So after that, we're gonna go to our machine. So this is our machine here. There are our grips. You can see the grips are there, so the top ones and the bottom ones. All right, so now what we're gonna have to do is to put our sample between the grips and start stretching it until it fractures. So okay, so first I'm gonna have to hold the sample. So I'm gonna hold the top of the sample and then the bottom of the sample. There we go. Okay. Once I'm done with that, I'm gonna go toward my computer and start doing the test. Okay. So yeah. Okay. So check now. There's my graph static. So now this is in the range of elastic deformation. As you can see, my line, the graph is going on a straight line. It's going on the straight line, and graph is straight. So look at the sample. The sample is being stretched now. It's being stretched. It's being stretched. And what we're gonna do is, once the sample breaks, we're gonna have to record the maximum loads. Okay, we're gonna have to record the yielding load, and we're gonna have to record the extension. Okay, we're gonna have to record the extension, because it's with the extension we can get the elongation in terms of percentage of our sample. Okay. So as you can see, check there. Now we're turning on the zone of plastic deformation. You see that? So that was straight line for elastic. That is plastic deformation. So our sample is gonna break very soon. We have to expect our sample to break soon. Our sample gonna break very soon. You see, it is past the elastic deformation. Now it's in plastic deformation. Check now. It's gonna break. Yeah, be ready for the noise. Yeah. So now I'm at 370 something kilonewton. Check. It's gonna break now. It's gonna break anytime soon. It's making there. The noise anytime soon. Wow! It's broke at 371.11 kilonewton. Man, that's great, eh? That's really great. So now I can measure my extension. Okay. So previously it was 50 millimeter. So now if I have to measure my extension now, you see my marks there. So now I'm at almost that is 67.93. So 17.93 millimeter extension. That is great. So I'm gonna take the biggest extension. So I'm gonna measure properly though. This is just to show you. So now the biggest one is 73.43. Wow. So the extension is that one minus 50 millimeter, which is 23.43 millimeter. That is a great extension. Okay. So I'm gonna capture my details here, my datas, and save the graph. Cool then, eh? Cool.